presentation of the final exam for Foundation of Computational Mathematics. So the problem one was asking to create two distributions and then do some probability calculations based on that data. So first I created the uniform variable with 10,000 values. So using n of 6. So here's a histogram of my big X, and it's uniformly distributed. Then I calculated the mean for my second distribution Y, so that's normally distributed with the calculated mean. So here's a histogram, normal distribution. So then I calculated the median of big X and the 25th percentile of Y, and did various calculation um, of probabilities. So here are the details, part A, B, and C. So the next step was to create the table of probabilities, and using that investigate um, those marginal and joint probabilities. So here's my table, and so here are the various probabilities that I found using this table. And the next step was to check whether the independence holds by Fisher's exact test and chi-square test. So I used these two functions in R to calculate that. So according to the Fisher test, um, the, the independence was confirmed, and same with the chi-square test. And so Fisher's exact test is more appropriate for this due to the size of our data, number of values. So problem 2 was to compete in a competition predicting house prices. So the first step was descriptive and inferential statistics. So we just load the data and then kind of take a look at it. So the first step was to load both the train and test data set. And then we did some descriptive statistics to take a look at what we're working with. So just looking at the data set to see what sort of variables we have. Some are numeric, some are categorical. So also I did a summary just to get more information on each one of those variables. So, what types of variables they are, what's the maximum, minimum, mean. So, like, year remodel was done. So the mean is 1985, max is very recent 2010, the oldest was 1950. So things like that. And also, I did a separate summary for just the sale price, which is the variable that we're gonna try to predict, just to see if there are any like significant outliers, and it looks fairly consistent. So I also did a histogram to kind of investigate the same thing. So it looks to be normally distributed, a little bit skewed to the right. And then I kind of dived in and did some plots to see what sort of connection we saw between the various variables and our variable we're trying to predict, just to kind of get my head around of what I'm doing here. So I did a box plot just to see how overall quality correlated with the sale price, and like there's clearly a very significant correlation. And I also did a box plot with the number of fireplaces in the home. So I figured, the more fireplaces, the fancier the house is, the higher the price would be. So it kind of looks like there's a connection, but it's not as kind of significant as I would have predicted, but there's definitely a link there. So next, just more of a big picture, I created the scatter plot matrix with some variables I thought were significant. So it looks like pretty much all the variables I selected, like lot area, garage area, number of rooms, things like that. So everything, if you look at the correlation with the sales price, like everything seems pretty significant. So I created a correlation matrix as well. And that also showed that, garage area, um, number of rooms, living area. So everything is, that I suspected shows a strong correlation. So I did some hypothesis testing to see if there's correlation. So in all of those tests, or for all 5 of those variables, all of those tests pretty much resulted in a p-value of 0. And so we were able to um, conclude that there is correlation between all these variables and the sales price. So I did 5 of those tests. So the next step was linear algebra and correlation. So we inverted the correlation matrix and then also conducted an LU decomposition. So here is the inverted matrix. So here's our original matrix. Here's the inverted matrix. And I multiplied the two just to make sure that we got an identity matrix as a result. So, and I did it both ways, correlation to precision and then precision to correlation. And then for LU decomposition, I used the LU function in one of the packages. So, and then, so here's the L matrix and the U matrix. And then just to validate, I multiplied L and U matrix and compared that to our original correlation matrix. And as you can see, they're identical. So part 3 was fitting an exponential model to one of the variables. So I used the living area as a variable. So first made sure that there are no negative values there, and then created a fit, and so the resulting fit is exponential, and here is the histogram of the initial variable. And when I did the 95th percentile calculation with our exponential data, so this is the result for that. And then I did the 95% confidence integral of our actual data, and using the normal assumption. And then I looked at the actuals. It seems like the normal was a better fit for this. And then as a last step, did some actual modeling. So build a regression model using a variety of variables. And so there were a lot of benefits to coding certain variables as categorical variables as factors. So that significantly improved my R score. So basically I just tried different things. I think until I came up with the best model. So it looks like very significant correlation was observed with a bunch of these factors. I mean, clearly neighborhood, that's gonna, like, certain neighborhoods are gonna be very strongly correlated with the price. Like conditions. So interestingly, the months sold. So I guess you hear that certain, like, real estate is like better to be purchased in a certain time of year. So I guess like summer versus winter. So that was confirmed. So basically just played around with the model until I got the best result. So things like number of bathrooms. Um, so I got a pretty good R squared value of 0.885, and p-value of 0. So and then just to kind of validate the assumptions, I looked at the residuals. They look pretty good. There's a bit of variance over here, but overall pretty good. So then I used my model to do a prediction on the test data and created a data frame with ID and sales price prediction, which is the requirement for the test data. I'm sorry, for the submission for the competition. So I came up with some NA values in that. I think due to the fact that um, you know probably could have done more to kind of clean up my data set before I did the analysis. So just to kind of avoid submitting blank entries, I just used the mean of the sales price to fill in those blank values. So created the submission file and submitted it to the competition and got a score of 0.22252. So that's it.